Thank you very much, and good afternoon, everyone. My name is Matthew Day, and I'm the Global Head of Risk Engineering and Loss Prevention for Generali's Global Corporate and Commercial Division. With me today is Adrian Diaz de la Raza. He's our Head of Risk Engineering and Loss Prevention for the region Iberia and LATAM. So, before we go into our topic today, as you can see on the title, the topic we will be talking about, the project that we've embarked on, is called Metaverse, and it's harnessing the Metaverse for risk engineering and loss prevention. But before we go into the actual project, allow me to just quickly explain who we are and what we do. So at GC&C, we have a risk engineering network of around 100 risk engineers. So they're based in many different regions around the world, mainly in Europe, but we have risk engineers in Asia and in the Americas also. It's a global network. We collaborate together when it comes to risk engineering activities and topics. The risk engineers have technical capabilities in different lines of business. So we have many property risk engineers, but also we have guys looking at construction risks. We have people looking at casualty, liability risks, now cyber risks, and also marine. Something that I'm super proud of as being the global head of this function is even though we're working with the global corporate and commercial side of Generali, we are actually considered in the Generali group as the go-to people for anything risk management or loss prevention related. So this is really good for us to have these discussions at a group level. The value proposition that we have is, first and foremost, to be the trusted partner for our clients. We don't want to be a provider that just says, follow this standard, this is what you need to do. We pride ourselves on actually understanding the client more, understanding the budget that they have, understanding the type of business that they have, so what they're dealing with in terms of hazards. And this is something that we think, if you understand that, then you are able to provide more pragmatic and effective risk management solutions. And we don't see this as a day one, we want everything to be fixed. We would prefer to work with a client not just in 1 year renewal cycle, but in a long-term way, meaning that we want to get the client's risk quality from A to B to C to D and so on, rather than trying to fix everything in the first year because it's not possible. So it's more of a journey, and we see ourselves as that lifetime business partner. So let's talk about what we're here today to talk about mainly, which is Metaverse. Metaverse was a project that we embarked on about 2 years ago. We had an innovation day in the Generali Tower in Milan, and we had many vendors there looking at the technology that we wanted to create. It was a bit of an exploration day. Many different companies came, and we ended up choosing a company called Vection Technologies. I would say here, this is a good point to mention, that actually this project wouldn't have been possible without the assistance from the Generali Group Innovation Fund. So they helped to fund this project and bring it to life. So we're very lucky, I would say, that Generali is super supportive when it comes to innovation, AI, and technology, and that we're able to have this funding available to us. So what is the technology? So the technology, as you can see here, if you can read on the screen, there's two types of technology that we use. One is virtual reality. Now, this is not uncommon probably to everyone in the room. Virtual reality is a bit like playing a PlayStation game or a video game. So you, as a character or an avatar, you're interacting with other avatars inside the same virtual environment, and you're able to, whilst interact with them, but you're able to interact with digital objects. The second part, which is for the glasses here, is the augmented reality part. So this is basically using the room that we're in, or the environment that we're in, and then overlaying video, images, and text. This basically brings to life the experience for the user inside their own environment. So it's not a virtual environment, it's actually their environment. This is something that we will showcase in a moment whilst I explain what the project means to us. Adrian will go down and showcase exactly how this works. But before we do that, we will just quickly explain how we will use it in the future. So The first use case with the virtual reality will be used for training and development. Many moons ago, I was a risk engineer myself, and I was a young risk engineer, so I went and did lots of training with senior risk engineers. And of course, I used to go on site with them, shadow them, be with them, and try to absorb as much as I could. This, of course, is a method that will always be relevant and will always stay. We encourage our risk engineers to read technical information, technical documentation, again, something that will be here to stay. But in my own experience, I was based in the UK at that time, you can't see every occupancy, you can't see every industry, because maybe the country doesn't have that industry anymore, or maybe the travel and the expenses is too far to travel outside of your country. So this is where we feel the virtual reality will really help bring to life the experiences that risk engineers may not get to see in real life. So what did we do? We have created so far, it's only just kicked off, we've started with 4 different types of occupancies. So they are plastic manufacturing, pharmaceutical manufacturing, food and beverage, and a logistical center. And the idea is here that we can put training modules inside these factories. So it might be something like a quiz, it might be something like just a walkthrough of the hazards, it might be like a hazard spotting exercise. So we want our risk engineers to really understand what they may see in these environments and which hazards and which areas of the facility they need to focus on, rather than trying to do everything or maybe focusing on the wrong things. A quick example of this is why it's so good, because we created a virtual sprinkler room, so where all the sprinkler pumps are and the sprinkler valves are, and we've got 15 hazards inside the room, so 15 things are wrong inside the room, and the risk engineer has probably around 15-20 minutes to find all of the 15 problems. And why is this important? Because when we look at claims, buildings that have sprinkler systems that end up burning to the ground, the reason why the sprinkler system didn't operate, 70%, I think the statistic is actually the sprinkler system was turned off. So if we can go into a sprinkler room and see that the valve is off, this will save us millions and millions of euros. It sounds simple, but again, I've done the job myself. Often, I used to see valves closed, very often. So it's something that we think this can tackle these small recommendations, but really effective when it comes to claims. The second part here is about I call it bringing recommendations to life. So what does it mean? It means, again, I had my own experience, so I just try to explain it from my side. I worked in London, and then I moved to Hong Kong, so I did many surveys in Asia also. But often, it was a very common situation I came across when we would write a report, and it would have recommendations inside, saying you need to do this because of this reason, etc. Sometimes that was not so easy for the client to understand. Maybe 1, because they never had this incident, maybe 2, because they haven't even seen it on the news, maybe 3, because they think maybe it will never happen to them. So sometimes just the text is not really giving it the credit it deserves. So we decided with the project to create the augmented reality. So we're able to put the recommendation inside the room that they're in, and show them if the recommendation doesn't happen, this could be the potential loss. So you could have a big fire because of this reason, that reason. You could have a big loss in terms of flooding because of this reason, that reason. And this should, I hope, and I really do think this will happen, is that it will bring to life that recommendation and make it more visual for the client to really understand why they should be investing in risk mitigation. So now I'm going to hand over to Adrian. Adrian is now over here using the glasses, the Apple Vision Pro glasses, and he will demonstrate some of the scenarios that we've created. You can watch the screen, because if you watch him, he's not doing anything really apart from this. So if you watch the screen, you'll see what he sees inside the glasses. Adrian, please.
Okay. So as you see with these glasses, we can see all the reality, all the room in which we are. So now here in this excellent building in Barcelona, but we can be in an industry, in a factory, in any place, in a wind farm, imagine everything. So if you can give me a little bit of space here, I will recreate one of our typical scenarios that we have in an engineering survey, okay? So, as you see, this is the typical app store that you normally see in an iPhone, have here in front of me. So I'm going to select Generalist app. Here you have. Go there. And we have a message here. So welcome to the collection of risk scenarios developed by Risk and Loss Prevention Generali. This simulation will show the consequences of some claims in working environments. So we go, and I can choose one of those that we have built. We have sprinkler obstruction, solar panel, electric panel, transformer break. So I will choose the first one.
Welcome to this augmented reality simulation, addressing the critical underestimated risk of sprinkler system obstruction. In this simulation, you'll experience a fire event where delayed suppression results directly from a physically obstructed sprinkler head by violating clearances prescribed by sprinkler standards.
So as you can see, it's a voice explaining everything that you are going to see. So we go next.
Begin by carefully scanning your surroundings, floor, walls, and ceiling to enable accurate positioning.
So I'm going to scan all the environment. So the glasses and the stand is going to adapt to all my environment, okay? So as you can see, it's adapting, it's detecting the wall, the floor, okay? So when we are ready, we click.
Choose a suitable space where place a virtual rack can be positioned and confirm the placement when ready.
Okay, so I will place the rack of sprinklers. Looking, okay. So for example here, it's fine. You see the green. So here we have. So now you are here, but I'm looking at a rack. Everything is prepared. So as you can see, we have a pipe, a sprinkler's pipe there, red sprinkler pipe. The sprinklers in the middle, and all the boxes, they are really, really close to the sprinkler. So we can start the stem, and it will simulate a possible claim, a possible fire.
At the start of simulation, a technical issue of the ceiling light will cause a burst of sparks that will hit the boxes. That will instantly cause a small fire that will gradually become larger and larger. When the fire reaches a certain height threshold, the sprinklers will activate to extinguish the fire. But in this case, the sprinklers are blocked by the boxes on the top of the shelf, and this will not stop the fire, which continues to flare up in the room. You've just witnessed a sprinkler failure caused not by system defect, but by improper spatial configuration. Obstructed discharge from sprinkler heads is one of the leading causes of fire escalation in facilities with otherwise compliant fire safety systems. Consequences include rapid flame spread, potentially leading to total asset loss, and most critically, elevated risk to personnel.
Okay, so after explaining me the consequences, we can go next.
To prevent obstruction-related failures, compliance with NFPA 13 and NFPA 25 is essential. Recommended mitigation strategies include: maintain a minimum of 457 millimeters vertical clearance between the top of storage and horizontal sprinkler deflectors. Conduct regular obstruction assessments as part of quarterly fire system inspections. Train facility staff on passive sprinkler obstruction, including unapproved signage, lighting fixtures, or seasonal decorations.
Okay, and now if we click on prevention, we are going to see if the client does properly, how we can avoid the claim. So we click in prevention. And now you can interact with the SEN. So me, as maybe one of the risk manager of the factory, or maybe the head of maintenance of the factory, I can interact and say, okay, if I move these boxes from here, maybe the sprinklers we will do their job. Yeah. So as you see, you have to move the boxes by touching them. So I will move them, go with my hand. Okay. So I move them. Now you can see the sprinklers are free. So successfully move it. I will click play. It recreates again the possible claim, the fire starts. But now the situation is different. So you see sprinklers work properly, you follow the recommendations from your risk engineer, and you avoid the fire in your factory. Experience finished. You go home, everything finished. I don't know, Matthew, we have time. We can show another one.
Yeah, sure.
So I can go with another one. For example, transformer breakdown.
Begin by carefully scanning your surroundings, floor, walls, and ceiling, to enable accurate positioning.
As you see, the quality is quite easy to move whenever you want. So I can go here, I can go there. Oh, no. Maybe the connection, no? I cannot move from here with the computer. 1 second. So
Welcome to an augmented reality demonstration.
I will go a little bit quicker. So I scan the stands, go there, ready.
Choose a suitable space where a virtual transformer can be positioned and confirm the placement when ready.
So imagine that we are in an electric room in a factory. We put a transformer, industrial transformer, really big.
You are now observing a pad-mounted transformer operating under nominal load. However, unnoticed overloading during peak hours has accelerated insulation deterioration and increased moisture ingress inside the tank. Over time, that will cause an insulation breakdown inside of it, and partial discharges develop across the degraded paper oil insulation system. The arc vaporizes oil instantly, generating high-pressure gas and leading to tank rupture and external fire that will sooner cause an explosion of the transformer. You've witnessed a typical but severe transformer failure scenario, capable of causing extensive electrical outages, fire hazards, significant equipment damage, and posing immediate dangers to personnel and operational continuity. To mitigate transformer-related risks, regular monitoring and proactive maintenance, such as routine insulation testing and thermal imaging inspections, are critical. Implement automatic cooling and overload protection mechanisms according to regulatory standards.
So the same, we can do prevention action. So you have to follow the instructions, find and sign the form near the transformer, and press play. Where is it appearing? Okay. Here we have. It's here. So the technical person in the factory should do this. Checking. Everything is fine, so the transformer is successfully verified, and we can go and continue. So it's basically to put in practical what the industry normally does in a recommendation report, okay? This is what we are doing. So we go here, we play. That's it.
Okay. I think maybe if we have a volunteer from the audience, they can try the glasses with a different scenario, just to see how it looks inside the glasses. Jack, please go over to Adrian.
Structural vulnerabilities can quickly escalate into substantial operation. Begin by carefully scanning your surroundings. Identify a virtual open area within your environment. Where to visualize a virtual flooding scenario.
So now what we are going to see, it's more normal or typical claim that also you can have at your house, okay? So we are going to put the window, for example, here, okay? And we are going to see a torrential rain experience. Let's go.
At the start of the simulation, a heavy rain begins outside the visible windows. Gradually, due to clogged drains or poor sealing,
It's raining in Barcelona.
rapidly flooding the space. Observe carefully as items, tools, and storage boxes become buoyant and float freely, illustrating the extent of potential damage. You've just observed how a standard rainfall event can result in flooding-related operational failure when critical drainage infrastructure is under-designed or poorly maintained. Consequences include electrical system failure, product loss, microbial contamination, and prolonged business interruption. To mitigate flood risks, ensure proper maintenance of drainage systems, regular structural inspections, installation of water barriers, and emergency preparedness plans for swift response to weather emergencies.
Okay, so So you have just seen how following the recommendations of a risk engineer, a client can avoid a claim.
So I think this is pretty much on time in terms of the schedule. So this was what we wanted to present to you. This is a project that took us a couple of years to get from the beginning to where we are now. We officially launched this actually on Wednesday, so 2 days ago, and we took the opportunity to use the ITC event to do our first external presentation on the project. So thank you very much for listening, and I hope you enjoyed.
Thank you.